Question number 34. Three conducting loops X, Y and Z are moving with the same speed from a region of zero magnetic fields to a region of non-zero uniform magnetic field. So what is the difference between X, Y and Z? See, this is having some area. Well, first what we'll do is, let me assume the length of this square of the side is equal to some X over here. So this will be 2X. What will be this one? This will be 2X and this will also be 2X. What will be this? This will be X and this is 1, 2, 3, 4. This is 4X. Okay, let us first have some dimensions. Which loop will have the largest induced electromotive force at the instant of the loop enter the magnetic field? Where does it enter the magnetic field? It enters the magnetic field here. The moment it enters the magnetic field here, what will be the EMF? Why should an EMF be there? Because the magnetic field lines will be cutting over here. So how do you find out that? So we know that the flux is given by B into A, right? And your EMF, induced EMF, is equal to minus delta phi divided by delta t, which should now be equal to B is constant. So I will write delta by delta t minus of delta by delta t into BA. I'll remove this B constant and I will write this as minus B into delta A divided by delta t. Since it says it is moving the same speed, okay, so therefore now what we do is, I can also write this delta A by delta t. I'll do one thing. I will just say, okay, so this is the length of it. See, this is the length over here. So when this loop enters here, this is the area that has been exposed. When this one enters here, what do you see here? You can say this is the area that has been exposed. And when this enters here, what is the area it is exposed? This is the area exposed over here, right? So therefore, what is the area here? The area in this case is seen to be 2x multiplied by x, which is 2x squared. Okay, and then here what is the area? This is once again this area, this length multiplied by this length. You should not consider this because you know it is not inside the magnetic field. So therefore, this is once again 2x and this is x. So which should now be equal to 2x squared. Now what about here? Here this is 4x and this is already entered here. There is nothing over here. So therefore, this is your x. So here it should be 4x squared. Now which of these cases area is larger? So the change in area is larger for 4x square over here, right? For loop Z. Okay, which means the EMF will also be larger. What is the question here? Okay, which loop has the largest induced EMF? Largest induced EMF depends only on delta A, the change in area, which is observed only for loop Z. So therefore, loop Z is the right answer. Z only is the right answer.